that normal distribution that we briefly talked about with the shapes a few videos ago. What I'm going to go over now is also sometimes called the empirical rule. Just a little note here. If you Google the empirical rule, the normal distribution, our textbook and therefore MyMathLab uses, they go ahead and round some of the percents to the empirical rule to the 10th place. So you might see different percents there. So make sure to use the numbers that I'm going to go over when working through MyMathLab. I'm going to keep it standard to MyMathLab. That way you know you're going to get the answers right. So if you've taken a statistics class before, you might be tempted to say, why did you round? I'm just going to be consistent with the authors, and that's why I chose to round the way I did. So the normal distribution takes our data and forces it to fit this bell-shaped curve that we have here. So no matter what people score, majority are going to be in this middle part. Only a few people are going to be up high and a few people are down low. So anytime you take a standardized test, like your Praxis, your SAT, your ACT, any of those specialty tests, your end of course test, any of that stuff, it's based off of what other students scored on it. So it doesn't matter how many you got right per se, but it matters how many you got right in relation to everyone else and the data that was being collected. So for instance, in our course, an A is 90 to 100. A B is 80 to 89. I could have every person in here score somewhere between 90 and 100 and we will all get A's. If I was doing a normal distribution or a bell-shaped curve, or what sometimes professors call grading on a curve, that would not be the case. I could only assign a set number of A's. I could assign a few more B's. Almost all the class would get a C, less D's, and only a few F's. So that means an A is not 90 to 100. An A might be the top 2 students in the classroom, and then an F would be the bottom 2 students, no matter what your actual numerical grade was. Then a B might be the next 5, and then a C would be, 15 of us, and then we would go down from there. So it's based off of making sure that everything has this shape to it, as opposed to everyone getting a percentage of the points right. So what I'm going to go over is the data that goes with the empirical rule. What I'm going to write up here does not change. So these are the numbers that we're going to need to have memorized. Straight in the middle right here of the curve here is our mean. So our mean is going to be in the middle. Then we're going to have to go over what we call standard deviations. And there's a formula for standard deviations, but for the purposes of our class, you don't have to have the standard deviation formula memorized. I'll give it to you. We're going to think about this being a number line, the mean being kind of like our origin or 0. So to the left is negative. So this is -1. And I'm just going to write standard deviation to save space. Over here, I would have +1 standard deviation. So over there would be +1. So we go to the right would be positive, to the left is negative. Now every single time, 34% of the data is going to fall from here all the way over to that blue line. And that means it's going to be the same on the right-hand side because this is symmetric. So there'd also be 34% on this side. So 68% of the data falls between the green line and the green line. So you'll see that written out a lot too. 68% of the data between the green line and green line. Now I can keep going. So I can go out another standard deviation. And this part is going to be less because our curve's dipping down. So this is going to be 13.5% of my data. And of course, if it's on the left, it's also on the right. And this is going to be 2 standard deviations out. So this would be -2 standard deviations. Over here on this side, it would be +2 standard deviations. Standard deviation is just what we're going to count by. So maybe our standard deviation was 5, we'll be counting by 5s or 2s or whatever it is. And we're talking about education. Our regular ed students are going to fall right here in this green. Students that are below the mean, but within 1 standard deviation, typically are not going to get support. You're not over here till you're 2 standard deviations away that you're going to start getting any sort of reading support or special education. You have to be so far away from the mean when you collect data for to get any sort of support that way. I can keep going. Let's see. So I can actually go out 3 standard deviations. This is going to be this tiny little bit. I'm not going to be able to write it in the space. But it's this little bit right underneath here is 2.4%. This is where, if you've taken a class before, our textbook goes ahead and rounds to 1/10. Or if you watch another video somewhere. So that is 3 standard deviations out. So to the left is going to be negative, and to the right it's going to be positive. Now, if you're ahead of me, you might have already added these up and you realize that it's not quite 100%. We do have a small percentage that is going to fall way extreme. So above 3 standard deviations and below 3 standard deviations. These are like, you know, your super geniuses that go to college when they're 12. And down on this end, we have like a severe special education. Maybe they're institutionalized or receive care in a hospital or somewhere else like that. So we do have a percentage that falls kind of outside of this curve. It's just a tiny, so it's 0.1%. So not even a whole percent is on the outside of our data here. So if you have these percents memorized, and it's symmetric, so you really only have to memorize one side of it, the problems are going to come pretty easily to us. So let's take a second and look at some of these problems. You're going to want to keep this picture close by so you can kind of see how they work. I'm actually going to work this problem down here based off of my chart. So I'm just going to keep it right there on our same screen. So you can see I'm going to give you the mean and the standard deviation. The mean's my origin, so I'm just going to come up here and say the mean was 86. So I'm going to plug in 86. My standard deviation is 2, so I'm going to count by 2s. So this one standard deviation would be 88. Then it would be 90. And then 92. Then I have to count backwards by 2s. So from 86, so I get 84. 82, and 80. You don't have to draw the picture if you don't want to. I know some people don't like to have the visual there. You're more than welcome to. I think it helps me at least have the number line out there and then somewhere to write these percents since we do have to have the percents memorized. So our first question says, what percent of students had a reading over 86? Well, some people are going to see this and say, well, 86 is the mean, so to be over 86 had to be 50%. And that's completely right. You wouldn't have to necessarily show any work for that one. However, they're not all going to be that easy. So if you did not remember that, that's okay. Above 86, 86 is this blue line right here. So I'm going to just add up all the percents. So I'd have 34% plus 13.5%. plus 2.4% plus 0.1%. So if you type all those in the calculator, you're going to get 50% again. So here's another one. This one you can't really do the cheating little 50% thing. We want to know what percent of students had a reading between 84 and 86. So that's the green line to the green line. I actually kind of gave that one away earlier. I said 68%. But you can also add these up. So you can say 34% plus 34% is equal to 68% there. Just a little word of warning on when I grade these. There's not a ton of work to show. So if you have the percents and you're really confident you have them memorized, then you don't have to show me this. But if you do mess up a percent and I don't have like this number line up here to kind of go by, then I can't give you partial credit. So I would encourage you to at least make the number line. That way if you get the percents messed up, maybe I can give you partial credit based off of your wrong percents, kind of based off of what your number line might be. The last one here is a little bit different. It wants to know between what two masses does 95% of the data fall. So this one I've got to kind of play with the numbers a little bit. I want to figure out what's going to add up to 95. Notice it is symmetric. So I'm going to kind of start in the middle here and keep adding up until I get to 95%. So if I were to go out to the green bars, that would be 34 and 34. As I know, that would give me 68%. So that's not quite enough. So I'm going to go out again. So I would have these green ones. Now I'm going to add the red ones into it. So that would give me the 13.5% plus the 34% plus another 34% plus the 13.5%, and that's going to equal 95%. What I exactly needed it to be equal to. So now I know it's from this red bar to the red bar. So it's from 82 to 90. So that's the actual answer, is from 82 grams to 90 grams here. One last word of warning. Make sure you understand the percents is the area between the lines. Down here, the 80, 82, 84, they go actually on the line. That way, when you're trying to figure out that last one, you'll realize that it goes all the way over to this 82. And the percent is the space in between it. Kind of like if we were reading a ruler.